All right, so you know how everyone's got that like stack of stuff about James Clerk Maxwell?
Yeah, articles, biographies, even like a textbook or two,
Yeah,
maybe.
we're gonna like try to like cut through all of that
Yeah.
and get to the good stuff.
Right.
This deep dive isn't just about equations,
You're right.
though they're important.
Well, they are very important.
But this is about understanding why Maxwell is considered like one of the greatest minds, right up there with like Newton and Einstein.
Absolutely.
So let's picture 19th century Scotland for a minute, right?
Okay.
A world that's kind of on the edge of this massive technological change.
Yeah,
That's where our story begins.
it is.
So are you ready to find out why Maxwell is considered like one of the greats?
I am definitely ready.
What's so captivating about Maxwell is that like even from childhood, there's all this curiosity.
Yeah, there's these great stories of a young Maxwell just constantly asking, like, oh, what's the go of that?
Really?
Yeah, about how things work. So it's that drive to figure things out that really set him on this path.
And it wasn't just like little kid stuff.
Bro.
Like this guy published a scientific paper at 14.
14 years old.
Yeah, this wasn't just some school project.
No.
This was about the geometry of ovals and curves.
Wow.
Yeah, the math was already off the charts.
That's incredible.
It's important to remember, though, that his early life wasn't perfect.
Of course not.
Losing his mom so young,
Yes.
must have had some kind of impact.
Absolutely, a big impact.
But his dad was a lawyer who really valued knowledge and nurtured Maxwell's education.
Right, so that foundation sent him to Cambridge.
Oh, wow.
Right at the time when it was just like this hub of intellectual energy.
Cambridge seems like the perfect place for someone like Maxwell
Absolutely.
to just thrive.
Oh, yeah.
And this is where things start to get really interesting.
Okay.
He gets kind of like absorbed by Michael Faraday's work on electricity and magnetism.
Right?
And Faraday was this brilliant experimentalist, but he didn't quite have the math skills to describe everything he was seeing.
That's right. Faraday could observe an experiment, showing these connections between electricity and magnetism, but he couldn't express it with mathematics.
Oh, interesting.
And that's the gap that Maxwell saw.
I see.
He realized he could use his mathematical genius to like solidify Faraday's ideas
Go ahead.
to give them a framework.
So it was like a partnership then
It was.
with Faraday doing the real-world observations.
Yeah.
And Maxwell coming up with the mathematical models to explain it.
Exactly. It's a beautiful example of how science builds on itself.
I like that.
What Maxwell achieved was extraordinary.
Okay.
He unified electricity, magnetism, and light into one theory.
Wow.
It's incredible.
Okay, so now we're getting into the famous Maxwell's equations.
Yes.
And I have to admit, like for a non-physicist, they can look a little daunting.
I mean, they look complex, of course.
Right.
But at their heart, there are 4 laws that are describing how electric and magnetic fields interact. And they're not just describing they're predicting what could be. Like, for example, his equations showed that electromagnetic waves could travel through space at the speed of light.
Hold on. So he's saying that light itself
Yes.
is an electromagnetic wave.
That's exactly it.
That's not just an equation on a page.
No.
That's changing how we understand the universe.
Right. It was a monumental leap. And to get there, Maxwell had to bring some serious mathematical power.
Like what?
Well, he introduced the concept of a field, this invisible space where forces can act.
Okay.
And he used vector calculus,
Oh, wow.
which was pretty cutting edge at the time to describe how these fields change and interact.
So it wasn't just like plugging numbers into an equation.
No.
He had to like invent new math to even describe these concepts.
Absolutely, and that's what makes him so brilliant.
Wow.
He didn't just apply existing math.
Right.
He created new mathematics to fit the physics that he was uncovering.
That's incredible. So was Maxwell like a one-trick pony, or did he do other things?
No, he wasn't.
I feel like there's more to uncover here.
You're right.
Yeah.
Maxwell's mind wasn't content with just electromagnetism.
Okay.
He made significant contributions to thermodynamics and the kinetic theory of gases.
Okay, now you're talking my language.
All right.
Tell me more.
Okay, so he developed something called the Maxwell-Boltzmann distribution.
Okay.
Imagine a container full of gas molecules,
Okay.
all zipping around.
Got it.
This distribution tells you how many molecules are moving at different speeds.
Okay.
So it's a way to statistically understand how those tiny particles behave.
So he's going from these huge forces of electromagnetism to the microscopic world of molecules.
He is, what a range.
Yeah, what a range.
And it gets even wilder.
Okay.
He came up with this thought experiment called Maxwell's demon.
What?
Yeah, this little demon challenges the second law of thermodynamics. You know, the one that says entropy or disorder always increases in a closed system?
Oh, yeah. Okay. I'm intrigued. How does this demon work?
All right, so picture a box divided in two with a tiny door between the compartments.
Okay.
The demon sits by the door watching the gas molecules move around. Okay.
When a fast-moving molecule approaches from one side, he opens the door, letting it pass to the other side.
Okay.
For slow-moving molecules, the door stays shut.
So he's like sorting the molecules based on their energy.
Exactly.
That seems like it would create more order, not less.
Right.
Which goes against the whole entropy thing.
Exactly. It's a brilliant thought experiment that sparked a whole lot of debate about the nature of entropy and how the second law really works.
Wow, sounds like Maxwell is playing with some really deep concepts here.
He was. And what's remarkable is he wasn't afraid to challenge established ideas.
Yeah.
He wasn't satisfied with just accepting what was already known.
That's a great segue to our next point, because his curiosity led him to some pretty unexpected places.
Oh, like what?
Like, did you know that he was a pioneer in color photography?
It might surprise you, but back in 1861, long before Instagram filters, Maxwell created the first color photograph.
Really?
Yes. He photographed a tartan ribbon using red, green, and blue filters.
Wow.
It laid the groundwork for the RGB color model we still use today. Wow, the RGB system in my phone.
That's right. That's James Clerk Maxwell, always connecting seemingly unrelated ideas.
It seems like we've only just begun to explore his work.
We have.
What other things are we going to find out about this guy?
Well, for starters, let's delve into his impact on the very institutions of science.
Okay.
Did you know that Maxwell was instrumental in establishing the Cavendish Laboratory at Cambridge?
The Cavendish.
Yeah.
Isn't that like a legendary place for science?
It is. It's become a world-renowned center for physics research.
Wow.
And it all started with Maxwell's vision.
Really?
He was the first Cavendish professor of experimental physics. But hold that thought. We'll dive into that in the next part of our deep dive.
Sounds good. It's amazing to think, like, we've got this guy, a theoretical genius who, like, dabbles in color photography.
Yeah.
And sets up one of, like, the most famous physics labs in the world.
Right.
Maxwell was a busy guy.
He was a force of nature, and it's sometimes forgotten that he wasn't just about these big theories. He understood how important experimental work was, you know?
Yeah.
That's why the Cavendish lab was so important.
You mentioned that he was, like, the first Cavendish professor of experimental physics.
Yes.
That wasn't just a title, was it?
No, he was very hands-on in setting up the lab.
So he was involved in, like,
Everything.
everything.
Designing the space, selecting the equipment, and making sure that it was all set up to produce reliable, cutting-edge research.
So he wasn't just focused on his own work.
No.
He wanted to advance science as a whole.
Yes, he was building a place where future generations could make discoveries.
It's really cool.
And he brought that same rigor to experimental design as he did to his theoretical work.
I see.
We often focus on the brilliance of his equations, but he was a champion of meticulous experimentation.
Yeah.
He believed in testing theories in the real world.
Right. It's a good reminder that science isn't just about thinking big thoughts.
No.
It's about putting those thoughts to the test.
Exactly. And the Cavendish, under Maxwell's guidance, became this breeding ground for major scientific discoveries in the 20th century.
So his influence kind of extended beyond his own life.
Absolutely. Way beyond.
Speaking of influence, how did Maxwell's work impact later scientists?
Well, you can't talk about Maxwell's legacy without mentioning Albert Einstein.
Oh, wow.
Einstein said that Maxwell's work on electromagnetism was the most profound and fruitful that physics has experienced since the time of Newton.
Wow. So Einstein's giving him props.
He is.
That's high praise.
It really puts into perspective how Maxwell wasn't just making small additions to physics.
Right.
He was fundamentally changing how we understand the universe.
Wow.
And Einstein built on that foundation.
Okay.
Like, his theory of special relativity was heavily influenced by Maxwell's work.
So the ripple effects are still being felt today.
They are.
What would you say is like the lasting impact of Maxwell's work on everyday folks?
I think Maxwell's life is a reminder of what human curiosity and ingenuity can achieve. It's about the drive to understand the world around us, the ability to connect different ideas, and the dedication to rigor in both thinking and doing experiments.
That's a great point. Maxwell's story kind of resonates with anyone who's ever looked up at the night sky or taken apart something to see how it works.
Right.
And asked, like, what's the go of that?
Exactly. He embodied that spirit of inquiry. And as we wrap up this deep dive, I want to leave you with a final thought.
Like,
imagine a world where Maxwell hadn't unified electromagnetism and light.
okay, so no Wi-Fi, No smartphones,
Right.
no radio.
Right.
It's hard to even picture.
It's a very different world. It really underscores how fundamental his discoveries were.
Wow.
So many of the technologies we rely on today are built on his work.
It's kind of mind-boggling.
It really is.
It makes you appreciate how, like, the pursuit of knowledge, even abstract theories,
Yeah.
can have such a huge impact on our lives.
It can.
But this deep dive has just been the tip of the iceberg.
It has.
There's so much more out there to explore.
Yeah. Absolutely. I encourage you to keep digging into Maxwell's life and his work, unravel the mysteries that still surround his legacy,
Yeah.
and keep asking that fundamental question, what's the go that?
You know, it's amazing to think about how, like, one person's work
Yeah.
can have this, like, ripple effect across time
It's true, yeah.
and all these different disciplines. I mean, we went from light waves to gas molecules to color photography,
We did.
all thanks to James Clerk Maxwell.
It speaks to how connected knowledge is, like
Yeah.
how a deep understanding in one area can give you insights into something totally different.
Yeah, it's like, it's not even just the discoveries themselves, it's the approach.
Yes.
Like this curiosity he had.
It makes you realize how much more is out there to find out.
Yeah, not just about Maxwell, but like about the world.
Absolutely. This deep dive was really meant to like spark that curiosity, you know, to give you a taste of what makes Maxwell so interesting.
Right.
But it's really just a starting point. I mean, there are so many books out there about his work.
So if you're listening and you want to go even deeper,
Yeah,
there's like a whole rabbit hole waiting for you.
there is.
And maybe you'll be inspired and do some exploring of your own.
I hope so. Maybe you'll tackle that problem that's been bugging you.
Yeah.
Or finally read that book you've been meaning to.
Yeah.
Maxwell's story shows us that the pursuit of knowledge is a journey worth taking.
Well said. And I think that brings us to the end of our deep dive.
It does.
We've covered a lot of ground.
Woo-ha!
You know, from Maxwell's childhood to his legacy on science and technology.
It's been a pleasure exploring his life and work with you.
Likewise. And to our listener, thanks for coming along on this journey with us.
Yes, thank you.
Remember, the world is full of wonder waiting to be discovered. So keep asking questions, keep exploring, and keep that curiosity alive.
Until next time.
Happy deep diving.